Yes, over the years, Lonza have typically made high titer clonal GSCHO cell lines using a random integration approach. And that was where the expression vector was transfected into the cell and then randomly integrated across the genome. And we then selected amongst the transfected pool of cells for high productivity clones. Lonza was then looking for a way to improve our ability to find these optimal integration sites within the CHO genome where genome expression is high and stable over the long term. And that's when we turned to our hyperactive piggyBac transposase technology. So in this platform, instead of randomly integrating vectors, we use an engineered piggyBac transposase enzyme that specifically inserts expression cargo into open accessible regions of the genome where genome expression is high and stable over the long run. The technology was originally isolated from the cabbage leaper moth, and it's been optimized and improved over the years. And Lonza's version of piggyBac has some key mutations that improve its efficiency of transposition. The way that we use it is when we're making a stable pool or a clonal cell line, we transfect into the CHO cell the expression vector along with the piggyBac transposase enzyme, typically in the form of a piece of optimized mRNA. The mRNA is then translated in the cell to produce the active transposase enzyme, which then binds to the sequences within the expression vector called inverted terminal repeats or ITRs. It then cuts out of the expression vector the cargo that's flanked by those ITRs and then integrates it into open accessible regions of the genome where expression is high and stable over the long term. Yes, so since we launched the piggyBac transposase technology into our GS expression tools, we've noticed a number of benefits from the technology. If we look at the stable expression format space, particularly focusing on the use of stable pools, we've noticed a number of benefits across a wide range of product types going from mAbs, bispecifics, and other therapeutic formats. These benefits typically are focused around the speed of stable pool recovery under MSX selection. And if we compare stable pools made using the piggyBac system versus our legacy random integration process, we typically see that stable pools made using piggyBac will recover under those selection conditions several days earlier, and that will allow you to move into your fed batch process and generate significant quantities of product much quicker. As for expression titers, within stable pools, we've seen a general titer uplift across a wide range of product types, typically around 70% in our studies. Moving on to clonal cell lines, of course, at Lonza, we are using piggyBac to generate clonal cell lines to support all our services customers. And there we are seeing quite nice increases in titer, again, across a wide range of product types. Yeah, so it's very easy to use the piggyBac transposase technology. It integrates pretty seamlessly into standard stable expression workflows. The Lonza GS gene expression vectors, a company called G-Squad, have been optimized to work with the piggyBac transposase technology. They contain the piggyBac recognizing ITRs, so the transposase enzyme can take these vectors and insert them into those open accessible regions of the CHO genome for high-level stable expression over time. So all the user has to do is simply transfect in the G-Squad expression vector into the GS knockout cell line, along with the optimized piece of transposase mRNA, and then the rest of the workflow is exactly the same. The only thing users need to do is just watch out for early recovery of pools under MSX selection, because they may recover faster than they would have experienced with the random integration process. But apart from that, everything else is maintained. Stable pools and clonal cell lines work with all the latest generation of Lonza medium and feeds. So it's a pretty seamless workflow from start to finish. Yeah, so one of the benefits of using the piggyBac transposase technology for audio expression needs, going from transient to stable pools and then clonal cell lines, is that you can now use the same platform host cell line, either the CHOK1SB GS knockout or the GS effect cell line. You can use the same expression vectors, the G-Squad system, and the same transposase enzyme to support all your expression needs. So that just simplifies workflows going from early stage discovery through to commercial supply.